So let's look at exponent rules. (2019), holy moly. Okay. Exponent rules should be a review for everybody. You probably learned about exponents in, I don't know, 6th, 7th grade, maybe? But we're going to use a ton of exponents this semester. This semester is all algebra based. So if you hated the geometry from last semester and you like algebra, we'll get that this semester. I know I say this a lot, but it's probably my favorite semester overall. I like the stuff that we do. So, exponent rules. First of all, I'm going to give you a general thing. Can you tell me where the exponent is? It's the x, right? This is the exponent. Does anybody know what the a is called? It's a variable, yes, in this case, but I'm thinking of like a general term for what that could be. Oh, that's okay. It's called the base. So you have a base and an exponent. And then what is, maybe you know, maybe you don't, what is a to the x known as? No? Okay. It's a power. So the whole thing is known as a power. You have a base and you have an exponent. So we may use those words as we go through, and you should know what each of them mean. So let's start simple. What does, I don't want the answer, but I want to know what it means. What does 2 to the 3rd power mean? I think I heard it over here. 2 times 2 times 2. It means you multiply the base as many times as you have an exponent. So 2 times 2 times 2, because it's 2 to the 3rd power. And what is 2 times 2 times 2? 8. 2 times 2 is 4. 4 times 2 is 8. Now we have our calculators, and you can use your calculator obviously as you go through this, but it's important to know what things mean. So what does x to the 3rd power mean? X times x times x. Now if I multiplied x times x times x, what would I get? X to the 3rd. X times x times x would be x to the 3rd. It just is broken down. Okay, I don't have an actual answer for it. Now this one is going to be super important for us as we move through this semester. You'll see something like x plus 2 squared. What does x plus 2 squared mean?
2x to the 2nd power. Wait, no, you're wrong. I don't know.
Don't think too hard. Okay, so let's go back up to 2 to the 3rd. What does 2 to the 3rd mean? 2 times 2 times 2, right? 2 3 times. What does x plus 2 squared mean? How about x plus 2 times x plus 2? I have that term, that base, multiplied twice because it has a power of 2. Yes? No? Maybe? Yeah? Okay, so what about, I don't know. How about x minus 3 to the 3rd power? What does that mean? X minus 3 to the 3rd power. There we go. X minus 3 times x minus 3 times x minus 3. Okay, so it's taking your base and multiplying it as many times as your exponent tells you to. That is going to be super important, especially with something like this. I've said it before and I'm going to say it again. There's some of you that aren't listening to me right now, and you're going to tell me that x plus 2 squared is x squared plus 4. That is not correct. You cannot distribute an exponent in when there is a plus or minus sign. Okay, that is so illegal. It's like math murder. I don't know. That's all I can think of. Okay, you are not allowed to do that. Super important. So make a note to yourself, circle, highlight, bold. I don't know what you need to do, but x plus 2 squared means you take that quantity, x plus 2, and you multiply it by itself. Super important. We okay with that? Okay, I'm going to go with yes. Let's look at what is the difference between negative x squared and negative x squared. What is the difference between negative x squared and negative x squared? Any guesses? Let's start there. I don't care if it's wrong. I just want to hear a thought process. Yeah? Yes, one will be negative and one will be positive. Which one will be which? The one in parentheses will be negative, so the other one's going to be positive? No? Okay, so let's process through it. Tell me what negative x squared means. Negative x times negative x. Right? It's what's in parentheses, it's my base, and then it's squared, so there's two of them. Do you agree with that? What is negative times a negative? A positive, and x times x is x squared. Okay, so what does this one mean? This is the tricky part. What does this one mean? Okay, so do you see here how here we have the x and the negative and they're attached together? We know they're attached because of the parentheses and the squareds with everything. In this case, the squared is just with that x. So I have a negative on its own, and then I have x times x. The squared is just with that x. So here I have a negative times a positive, which is a negative x squared. Okay, so when the negative's in parentheses, it stays with that base. When the negative is not in the parentheses, it attaches out front. Okay. So let's look at these two. Negative 2 to the 4th, and then negative 2 to the 4th. So take a second with your group and see if you can come up with the final answer. So I want you to expand it out and give me a value. So a single answer for both of these. What did we get for the first part? Negative 2 to the 4th power. Can someone tell me? Tyler? Positive 16? Okay, so you have negative 2 times negative 2 times negative 2 times negative 2. Right? Negative 2 times negative 2 gave you 4. This gave me 4, giving me a total of a positive 16. Okay. In this case here, the negative attaches, and we just have 2, 2, 2, 2, which would give you negative 16. Now, do things change when I give you Let's do... What if I give you this? Negative 3 to the third versus negative 3 to the third. What do you get in that situation? So the easiest thing to do would be to break it down to what it means and then multiply it out. Someone tell me what the first part means. Anybody? What does it mean? What does negative 3 to the third power mean? Thanks, Tyler. Negative 3 times negative 3 times negative 3. You agreed? Okay, so let's multiply it. Negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27. Did you get that? Yeah? Okay, so what does negative 3 to the third power mean? I can't hear whispers. I'm old. Yeah. Perfect. There's the negative out front, and then it's just 3 times 3 times 3. Right? So 3 times 3 is 9, times 3 is 27, and then a negative out front. I get the same answer. So can we make an assumption about exponents and that negative and what will happen based on what the exponent is?
If it's an odd number, it's going to be a negative. If it's positive number, it's going to be positive.
Close. Okay, so she said if it's an odd number, I'm going to get a negative. If it's an even number, I'm going to get a positive. Almost. If it's odd, it doesn't matter if there's parentheses or not. Your answer will be negative. If there's a negative already there. If it has an even exponent, the parentheses make a difference on whether your answer is positive or negative. Okay, so if you see an even exponent, 2, 4, 6, 8, 10, and so on, you need to be careful with your negatives. If it's an odd exponent, it doesn't matter because it's going to stay negative. Are we okay with that? Yes? Okay. I'm kind of going to just throw a lot of rules at you, and we'll see how we do today. We may or may not get to homework. I'm sure you won't mind that, though, right? No? Okay, so let's look at the power property. Now, these are rules that you've learned. Whether you know them by name is a different story, but I think once I show you what the property looks like, you might remember what to do. So if I have a power, so a to the m times another power, a to the n, does anybody know what I do with my exponents? And you'll notice that my bases are the same, right? They're both a's. That's important. So if they have the same base and you're multiplying the powers, does anyone remember what you do with the exponents? You add them. Okay, so multiplying I know it sounds funny, but when you multiply powers, you add the exponents. So for instance, if I give you 3 to the 2nd times 3 to the 7th, what will our final answer be? Three to the 9th. You leave the base alone and you add the exponents. Does that rule look familiar? Yeah, to some of us? Okay. We also have a property called power of a power property. This is where I have a power raised to another exponent. Okay, so I have a power raised to another exponent. Anyone remember the rule here on what we need to do with exponents? I think I heard it. Multiply them. So it's a to the m times n. So we don't change our bases, we are just multiplying exponents right now. So if I give you 5 to the 2nd all to the 4th power, 5 to the 2nd all to the 4th power, what does that give me? I think I heard it. 5 to the 8th power, good. So you're just multiplying your exponents. Okay, the biggest thing is going to be remembering the rules. So far, so good? All of this is maybe coming back to us a little bit? Okay. Do I want to do that one next? No, I think I want to do this one next. Let's look at the division property. So for the division property, I have a to the m over a to the n. Anyone remember what I do with those exponents? See if anyone else can help me out with that. Someone already gave me the right answer, but I only heard them and they're sitting right next to me. So does anybody else subtract them? So if you're dividing powers, you subtract exponents. If you said it and I didn't hear you, I'm sorry. Remember, I'm old. You have to talk louder. Okay, so you're going to subtract exponents. So if you're dividing powers, you're going to subtract exponents. For example, let's just do a basic one. So b to the 5th over b to the 3rd. They have the same basis, so we subtract the exponents. What do we get? B to the 2nd power. We're doing all the basics right now because I want to make sure we understand the basics before we do anything too complicated. Okay, so again, power property, when you're multiplying the two powers, you add exponents. When you have a power to an exponent, you multiply the exponents. When you're dividing powers, you subtract exponents. Couple more. power of a product property. And I don't care that you know the names. You just need to understand the rules. Whoops. Power. Don't write product twice. That should say property. Try again. Okay. Now, before we go through the rule, what do you notice about this particular property in comparison to the rest of them? It's a problem, is what I heard. It's not necessarily, so we can't really do anything with what's in parentheses because it's an A and a B. If it was 2 times 3, sure, we can multiply 2 times 3 first, right? I agree with that. But what else? Give me something else that you notice. They're 2 different variables, so they're 2 different. They're 2 different bases. Okay? They both have different bases. Right? All of these have the same base. Agreed? Okay. So, when you have 2 different bases and you are multiplying, because up here, remember, we were adding and I said you are not allowed to distribute in that 2, because when you add and subtract, you are not allowed to do that. So if you are multiplying and there's 2 different bases, you are going to attach this exponent to both bases. So it would be a to the m times b to the m. So if the bases are different, you attach the exponent. So let's look at 2x to the 3rd all to the 6th power. Okay, so what I would like you to do is, you may or may not understand how to do this quite yet, but I want you to work with your group and come up with an answer. I don't care if it's wrong, I want you to try. So 2x to the 3rd to the 6th power. So use the information that I've showed you to come up with an answer. And I'm going to come around and see what you come up with. Okay. So, I specifically put it with this problem for a reason, right? This property. How many bases do you see? 2. I see a 2 and an x. Because that's really 2 times x to the 3rd, right? So, if I have 2 bases, I attach the exponent to each of the bases. So 2 to the 6th and to this x to the 3rd. But if this 2 wasn't here, what property does this fall under? The power of a power, right? So what do I do with those exponents? I multiply. What's 3 times 6? 18. Okay, which is why I'm 99% okay with your answer. Does that look like anything you have ever seen? Have you ever seen a problem that said 2 to the 6th, 18, or x to the 18th? No. What is 2 to the 6th power?
64. I didn't know. I did it 2 times 3 to the 6th power.
I gave you a trick one. It's okay. 2 times 2 times 2 times 2 times 2 is 64. And then x to the 18th. So some of you gave me 2x to the 18th, but didn't see 2 as its own power. Okay? As its own base. 2 is its own base. What is the exponent that is attached to the 2? 1, right? If it's not there, it's a 1. So really, sorry if y'all missed stuff on that. Okay. Are you okay there? Yeah? You sure? Sure? You want to try another one like that?
No.
Okay. That was so quick. Why not? They're not fun? Huh? Do one more? Okay, I'm going to give you one more. Okay. I don't want you to freak out when you see it. I want you to try it. I have faith. Here we go. It's okay. You can do it. You can do it. Take it one base at a time. One base at a time. One base at a time. Okay. So, I said take it one base at a time, right? How many bases do you see? 3. There's a 3, there's an X, and there's a Y. Okay, so one base at a time. So 3 squared. What exponent is on my X?
1.
A 1. And remember, you multiply. So that's X squared. And then I have Y to the 6th power, because 3 times 2 is 6. Some of you added. Last step that I would ask you to do is actually multiply this out. 3 squared is 9. X squared, Y to the 6th. Okay, one base at a time. Okay. Zero exponents. What?
That looked like a 7.
That's a Z. Sorry. 0 exponents. Now this question is always my favorite, and it's probably the easiest question you will ever get, and someone's not listening and will get it wrong. Okay. Are you ready? Anything in the entire world, anything to the power of 0 is 1. Anything to the power of 0 is 1. So A to the 0 power is 1.
How?
Plug it into your calculator. Anything to, don't plug in A, plug in like 2 to the 0, because there's no A. Anything to the 0 power is 1. You can't plug in A in your calculator, but if you do like 2 to the 0, does it give you 1?
Yeah.
Oh, shocker. Was that really exciting? Okay, what about 3x to the 0 power. 1. Nope. Because it's 3 to the 0 power, which is 1, and x to the 0 power, which is 1, and what's 1 times 1? 1. Okay? This one's tricky. Ready? 5,000 x y to the 6th all to the 0 power. Good job. Okay, so no matter what, anything to the 0 power is 1. Okay? Hardest problem you'll see all semester.
Teacher, what is 5 to the power of 0? That's a tough question.
This is not going on your TRF.
I don't understand, man.
Okay. Last thing I want to talk about, and then I'll let you pack up. Okay, negative exponents. Last thing. You cannot have negative exponents. We're not changing it to a 0. You don't get to just change things to 0 to make it all go away and turn to 1. That's not how it works. Okay, but you cannot have negative exponents. So, if you do, for instance, if I give you x to the negative 2, we're going to use the reciprocal to make it positive. What does reciprocal mean? Yeah, right? So it'll flip position. So right now this is technically x over 1, right? So if it flips positions, it would become 1 over x. And that 2 stays with the x, but it becomes positive. So this would be your answer, 1 over x squared. Okay. If it's in the denominator, so for instance, if you have 1 over a to the negative 3rd, again, you apply the reciprocal, and it becomes a over 1, and the 3 stays with the a, or you can just write it as a to the 3rd. Okay, so wherever the negative exponent is, it's going to flip. Now, I made it slightly confusing because of that 1, but we're going to look at that more tomorrow. But for right now, where that negative exponent is, it's going to flip. Okay? All right.